In this video tutorial you will learn basic concept of incremental conductance MPPT for solar PV and its implementation in Simulink MATLAB. Incremental conductance MPPT was developed to overcome the drawbacks of perturb and observe MPPT technique. The incremental conductance method computes the maximum power point by comparing the incremental conductance to the instantaneous conductance of solar PV array. When these two are the same, the output voltage is the MPP voltage. The controller maintains this voltage until the irradiation changes, and the process is repeated. The incremental conductance method is based on the observation that at the maximum power point, change in power with respect to change in voltage is equal to 0. Then, according to rules of derivatives, we can express dP divided by dV as shown. dV by dV is cancelled out and we are left with this expression. Now, since dP by dV is equal to 0 at MPP, therefore, by rearranging the equation, the maximum power point is achieved when the incremental conductance is equal to the negative of the instantaneous conductance. Please, note down these equations with yourself. If you don't understand these equations, then don't proceed because these are the fundamental equations for incremental conductance MPPT. Let me explain these equations from the power versus voltage characteristics of PV array. If dP by dV is greater than 0, this means that PV voltage is less than MPP voltage. In this case we have to increase the duty cycle. If dP by dV is equal to 0, then PV voltage is equal to MPP voltage. In this case, dV and dI will be 0 and the voltage must be maintained until the irradiation changes. And if dP by dV is less than 0, then this means that PV voltage is greater than MPP voltage. In this case we have to decrease the duty cycle. Now, let me show you how to implement these equations in Simulink MATLAB. But before that you should understand it through a flowchart. Once you understand flowchart of this algorithm, you can then better understand its Simulink model. Let's start. In order to learn Simulink model of this algorithm easily, each block has given a number here. The same number is given to the corresponding block in Simulink model. Let me first give you a brief idea of the flowchart of this algorithm. Now focus on the first block. Values of PV voltage and current are taken from the voltage and current sensors respectively. In the second step, values are delayed, or you can say stored in a memory. And the values in memory are replaced by new values from the sensors. This means that the values are stored in memory till the next step. Step time is equal to the sample time. In the third step, the previous values of current and voltage are subtracted from the present values of current and voltage to find the difference. In the fourth step, voltage difference is compared with 0. If the difference is equal to 0, this means both the present and previous values are same. And this indicates that no change has occurred in PV voltage during the sample time. So, if the difference of the two voltages is 0, then we have to check the difference of the two currents. The current difference is compared with 0. If the difference is equal to 0, this means both values of current are equal. So, if the voltage difference in block number 4 and current difference in this block are both 0, this means the irradiance remained same during the sample time. And therefore, we need not to change the duty cycle. And the process will be repeated until the irradiance changes. Now, consider if the condition at block number 4 is true but the difference of the current is not equal to 0. Then we have to go through block number 5. In block number 5, we have to see whether the present value of current is greater or less than the previous value of current. If the present value of current is greater than the previous value, then condition at block number 5 is true. But this means the PV voltage is now greater than the MPP voltage. Or you can say, it is on the right side of MPPT. In this case, we have to decrease the duty cycle to decrease the voltage. Now consider if the condition at block number 5 is not true. This means, the present value of current is less than the previous value. And in this case, we have to increase the duty cycle, because the PV voltage is now less than the MPP voltage. Or you can say, it is on the left side of the MPPT. So, the duty cycle is increased here, and then the process is repeated. Now, let's go back to block number 4. Here, consider the condition is not true. Then, we have to go through this block. The condition here is the same as we have derived previously for MPPT. If this condition is true, then, the system is operating at maximum power. And in this case, we don't need to change the duty cycle. Consider, if the condition is not true, then we have to go through block number 8. Now, consider if the condition at block number 8 is true. This means that the PV voltage is greater than the MPP voltage that is on the right side of MPPT. And in this case, the duty cycle is decreased to lower the voltage. And if the condition at block number 8 is not satisfied, then, the duty cycle is increased. Because, now the PV voltage is less than the MPP voltage. Hope you have got the basic idea of incremental conductance MPPT. Now, let me explain all the blocks of the Simulink model for this MPPT technique. Let me start with the PV array. I'm just opening this block to show you how to model your PV array. Here, you can select a PV module from the given list. These are different standard modules. You can also define your own module. Just select user defined here from the drop-down list. And then you can enter the specifications for your module here. After that you should give here the number of parallel strings. You should also specify the number of series connected module per string. You should select these two parameters according to your requirements of current and voltage. The important thing here is the IV, that is the current versus voltage, and PV, that is the power versus voltage characteristics of the PV array. After you put all the specifications, you can check IV and PV characteristics here. This is important, because we can find actual MPP from these graphs. You will learn more about it in the demonstration portion of this video. There are two inputs to this block: the irradiance, and the temperature. You should drag two constant blocks from the Simulink library to give these inputs. These are just constant blocks, and are renamed with irradiance and temperature. This is the terminator which terminates a signal. If you don't want to terminate this signal, just connect here a bus selector. Let me show you how to do this. Just select your desired parameters. Let me select the PV voltage and PV current. Now if you want to display these parameters, just connect display blocks from the Simulink library. Also, you don't need these two blocks, voltmeter and ammeter, because you can select the PV voltage and current from the bus selector. Let's proceed to the next block. The voltmeter and ammeter give PV voltage and current respectively. The voltage and current are multiplied here to get output power of the PV array. This is the DC link capacitor. You need to connect a supercapacitor here to get constant voltage. The value of the capacitor here is chosen as 3 millifarad. This is the boost converter. In order to have full understanding of Simulink model of boost converter, you should watch my video tutorial on boost converter. The gate is given a PWM signal, and the duty cycle of the PWM is controlled through the MPPT controller to extract maximum power from the PV array. Now, let me explain the blocks used in the Incremental Conductance MPPT. Here, each block is numbered. Now let's have a look at the flowchart. I have already explained this flowchart and its basic algorithm. In the first step, that is block number 1, the values of voltage and current are read. Let's see it here in the Simulink model. The values of voltage and current are taken from the voltmeter and ammeter. The values are then delayed for a duration equal to sample time. This block is represented by the number 2, both in flowchart and here in Simulink model. You can see the value of the sample time in the power G block. The value of sample time is 5 into 10 raised to power minus 6. The same value of sample time is put here. In step 3, voltage difference and current difference are calculated. The current difference is divided by the voltage difference, then multiplied by voltage, and the result is then added with current. You can see the expressions with each of these 3 blocks. These expressions will help you in understanding. In step 4, which is represented by the block number 4, the voltage difference is compared with 0. This is a switch, which passes the first input if the second input satisfies the given condition, otherwise, pass through input 3. The condition here is that, input 2 is not equal to 0. I have told you previously that the difference is compared with 0. But the condition is reversed here, because we don't have that condition here in the given conditions. I have right here, yes, and, no, which correspond to the condition given in the flowchart. Let me explain it again. The condition given in the switch is that input 2 is not equal to 0. If this condition is satisfied, then the switch will pass through input 1. This means the voltage difference is not equal to 0, and the condition given in the flowchart is not satisfied. And that's why I wrote, no, here. Just the condition is reversed here in this block. You don't need to get confused. If the voltage difference is equal to 0, then we have to pass through block number 5. You can learn it just by comparing the blocks with the same number. I'm going to explain you just one thing. In the Simulink model, 2 of the flowchart blocks are not considered. This one, and this one. These 2 blocks are not considered while building the model in Simulink, because if the conditions in these blocks are satisfied, then we don't need to change the duty cycle. When the conditions given in these 2 blocks are not satisfied, only in that cases we have to change the duty cycle. Hope you got this point. Here, output is given to saturator, which limits the values of duty cycle between 0.8 and 0.1. And finally PWM generator, which inputs the duty cycle, is connected to generate PWM.